Introduction to ARM architecture. After getting to know different microcontroller architectures, it's time to explore the ARM architecture as we're going to use STM32 microcontroller in this course, which is of ARM architecture. ARM stands for Advanced RISC Machines, is a family of architectures developed by ARM. It is one of the most widely used and popular processor architectures in the world, found in a wide range of devices from smartphones and tablets to embedded systems and servers. ARM architecture is based on the principle of reduced instruction set computing, that's RISC. RISC architectures aims to simplify the instruction set of the processor, which leads to a smaller number of instructions and simple hardware implementation. This results in improved performance, reduced power consumption, and easier design of the processor. A key features and characteristics of the ARM architecture. RISC architecture. ARM follows the RISC reduced instruction set computing design philosophy. RISC processors use a simplified and streamlined instruction set consisting of simple and atomic instructions, which allows for faster execution and easier pipelining. Processor modes. ARM processor supports different modes of operation, each with its own set of registers and privileges. Some of the common modes include user mode, system mode, supervisor mode, that's again a privileged mode, and IRQ interrupt request mode. So the processor modes are extremely important when you design a system which is of high security needs. So any system which is under user mode cannot access the resources in the supervisor mode and so on. So it's very important for a processor to support different modes for security reasons. The instruction set. ARM processors comes in various versions with different instruction set. The ARM v7 and ARM v8 architectures are among the most prevalent ones. ARM v8 introduced the ARC64 architecture which supports 64-bit processing, while the previous versions, that's ARM v7, primarily supported 32-bit processing. Thumb Thumb2. ARM also introduced the thumb instruction set, which uses 16-bit instructions instead of 32-bit, allowing for higher code density and reduced memory usage. Thumb2 further extends this concept, blending 16-bit and 32-bit instructions for improved performance. Pipeline architecture. ARM processors use a pipeline architecture where multiple instructions are executed simultaneously in different stages of the pipeline. This pipelining enhances the overall throughput and performance of the processor. Due to the use of pipelining, different instruction sets gets executed parallelly, which then increases the performance or the throughput of the processor. Endianness. ARM supports both little endian and big endian byte ordering, depending on the specific implementation. Little endian is more common in most ARM-based systems. Here let's understand the concept of endianness. Endianness refers to the way data is stored in memory and how the bytes of a multi-byte data type, such as integers and floating point numbers, are arranged. It determines the byte order of the data, specifically where the most significant byte, its MSB, or the least significant byte, the LSB, comes first in memory. Big endian. In big endian, the most significant byte is stored at the lowest memory address, and the least significant byte is stored at the highest memory address. It is as if the data is written big end first. For example, the 32-bit integer value 0x12345678 would be stored in memory as follows. The address 012, the value is 12, 34, 65 and 78. So here the MSB 12 is stored at the least significant byte, that is 0. So here you can see that the 1 2 is the most significant byte, which is stored at the 0th position, that is the lower memory address, and the least significant byte, the 78, is stored at the highest memory address, that is 3 in this case. The second is the little endian. In little endian, the least significant byte is stored at the lowest memory address, and the most significant byte is stored at the highest memory address. It is as if the data is written little end first. For the same 32-bit integer value, 0x12345678 would be stored in memory as follows. So here you can see the address 0, 1, and 2. The value is 78, 56, 34, and 12. So here the 78, which is the least significant bit, is written at the 0th position. And the 12 is the most significant bit, which is again written at the highest address. So that's about the little endian and the big endians. Memory management. ARM processors support memory management features like virtual memory and memory protection, which are crucial for modern operating systems and multitasking environments. So if you know a little bit of Linux, so you can understand that you can install Linux only if you have the process supports virtual memory, or the memory protection unit. So that's the advantage. So modern operating systems need memory management. So ARM provides that. Floating point unit, FPU. Many ARM processors include a hardware floating point unit, allowing efficient handling of floating point arithmetic operations, which are common in scientific and multimedia applications. So energy efficiency. One of the key strengths of ARM architecture is its energy efficiency, making suitable for battery-powered devices like smartphones and tablets, where power consumption is a critical concern. So you can also see that the ARM also provides like features like sleep mode and other uh, modes for the processor, which is basically useful in reducing the power consumption. So wide application. ARM processors are used in a diverse range of devices, including smartphones, tablets, smart TVs, IoT devices, routers, embedded systems, automotive applications, and more. So these days, ARM is everywhere. So that's the reason learning ARM is very crucial for embedded engineers. Licensing model. ARM Holdings licenses its processor designs to other companies, which can then incorporate these designs into their own products. This licensing model has contributed to ARM's widespread adoption and versatility. So ARM is an architecture which gets licensed, and in this case, STM32 is a processor from ST Microelectronics, and they get the ARM license and then they build the processor. So that is how we get the ARM processors out in the market. Similarly, other vendors like TI, NXP, there are so many vendors which use ARM architecture, which gets licensed from the ARM company. ARM's continuous development and adaptability have made it a dominant force in the world of computing, powering billions of devices and shaping the landscape of modern technology. Its efficiency, flexibility, and scalability have ensured its relevance in various industries and applications. So now we are introduced to the ARM architecture. In the remainder of this course, we're going to explore the ARM architecture and learn to work with it using STM32 microcontroller. Thanks for watching.
Subscribe to the channel for more projects, courses, tutorials, and tools.